The center of gravity technique requires you to reduce your surface area to a set of coordinates. Normally we're used to, in problems, those coordinates being handed to us, but this particular scenario is kind of a little bit more like what it's like in reality, in that it does not come with the coordinates. Let's take a look. Consider the following map of 6 cities, indicated by the 6 dark numbered points. All right, here, these are the cities. The 5 light-colored points labeled A through E are 5 candidate locations of a new warehouse to which to ship to the cities. Okay, fine. And then that's it, because it starts asking questions. It says, if the amount to be shipped from the new warehouse is equal to each of the 6 cities, which candidate? Okay, equal. Which should be the candidate for the new warehouse? Oh, well, actually what we need to do here is we need to determine first what the ideal location of the new warehouse would be on this grid, and then see, essentially, hopefully one of the candidate points will match it the closest or pretty closely. But how is it that we're going to determine where the new warehouse ideally should be on that grid? We have to number the grid. We need a numbering scheme. I think it's most logical to just start at 0 here. It's actually up to you. See, 11, 12, 13, 14, 15. So that we can read off the 9, 10, 11, so that we can read off the actual coordinate points of the cities. Because we have, let's think, city 1, 2, 3, 4, 5, and 6. That first question we were looking at, where should the warehouse be if the shipments are equal, is actually really easy to answer if we have these coordinates, because the only thing you do is you just average the coordinates together. But wait a minute, we don't have the coordinates yet. Let's find them. We need the x coordinate and the y coordinate for each city. So I'm just going to locate, let's see, city 1's right here. What is that at? That's right here on the edge. X equals 0 and y equals 10. City 2 is right here. What's that? Oh, x equals 5 and y equals 3. Then city 3 is right where x is 9 and 9 is 9. Okay, 9 and 9. City 4, where x is 10 and y is 2. Got it. City 5 right here where x, this is x, that's y, where x is 1 and y is 2. Okay, 1, 2, pretty close to the origin. And then last one, 6, where x is 14, right over here to the right, but y is only 1. Not very high up on this grid. Oh, now, answer that question? Easy. The optimal x coordinate for the warehouse, since the shipments are equal, will just be the average x. Just average 0, 5, 9, 10, 1, and 14. I get 6.5. That's the perfect x coordinate for it. Y, optimal. The perfect y coordinate, just average the y's. Okay, 10, 3, 9, 2, 2, and 1. Average those together. I get 4.5. Now, you might be tempted to, box these in as, okay, good, we got that part answered. But that's not actually what it asked. This is the coordinate of the optimal location for the warehouse. What the question asks is which candidate location, maybe they're bargaining for these places here, the light colored dots, which one should be the warehouse. So we want to look at which one's essentially just the closest match. So 6.5. 6.5 is here. Trace it up to 4.5. Oh, I think I see very obvious match here. Right on that spot. The actual answer to this question, you can see it right there, is location A. Okay, that's our recommendation. Now, oh, wait a minute, next question. There's more information. Suppose that the monthly amount to be shipped to each of the cities is as follows. Okay, so now it's getting more detailed here. 500 to city 1, 200, excuse me, to city 2, 500 to city 3, 100 to city 4, 300 to city 5, 100 to city 6. Given this new information, which should be the candidate for the new warehouse? Oh, all right. In this situation, in which the amount that to be shipped from the location that you're trying to location you're trying to locate, when it varies, the amount to be shipped, you want to calculate the weighted coordinate. The weighted coordinate, meaning that the optimal x coordinate is the sum of each of the quantities times the city that it's headed towards, divided by the sum of the quantities. The perfect y-coordinate, same thing. The sum of each of the quantities times the y-coordinate it's headed towards, divided by the same old sum of the quantity. Oh, wait, you know, we better organize this information, because here in a sentence, it's just going to confuse us. The easiest thing to do is make another column over here. Q for quantity, right? Always. Q for quantity. What did the sentence say? Okay, for city 1, 500. For city 2, 200. For city 3, 500. For city 4, 100. Then 300. Then 100. All right, let's do some calculation. Want to work on the x-coordinate. Okay, so for the numerator, what I need to do is take each quantity and multiply it times the x-coordinate it's headed towards. So, what does that look like? 500 times 0 plus 200 times 5 plus 500 times 9 plus 100 times 10 plus 300 times 1 plus 100 times 14. Remember, you always do your multiplication first. That's where I arrive at the conclusion that the numerator here should be 8,200. Now the denominator, that's pretty easy. The denominator is just the total amount that you're shipping. Okay, so I take this list and I add it up. I get 1,700 as the total, you know, sum of Q. That's what goes here. Which means that now the perfect x-coordinate for the warehouse is something more like 4.82. Where previously it was 6.5. Oh, okay, fine. Hang on to that fact. Down here, actually the denominator's already done. It's the same old 1,700. But we need to calculate the numerator. Go back to the data. 10 times 500 plus 3 times 200 plus 9 times 500 plus 2 times 100 plus 2 times 300 plus 1 times 100. I get 11,000 when you're done, which means that divided by 1,700, the perfect y-coordinate is something like 6.47. Once again, we've produced the perfect coordinate, but that isn't exactly what the question asks. The question wants us to locate one of those candidate, or recommend one of those candidate locations. Fine, we take this coordinate and let's see if we can find the closest match. Okay, so x is 4.8. It's a little shy of 5. And y is larger, 6.47. We're right in, there it is. We're right in here. Who's that? That's location B. That's the answer to that problem. Notice the difference between the first half of this scenario and the second half of the scenario. First half of the scenario, everybody was the same. That was the point. Second half of the scenario, some of the cities provide more, need more service. They need more shipped. That's the perfect point. It moved up, like to the north, and it moved a little bit like to the west. Why is that? If you look over here, where are the heavy hitters in terms of quantity? City 1 and city 3. See how they're higher on the graph? They're basically now pulling more or more influential, and the perfect place for the warehouse moves closer to them.